What's up, math fans? I haven't done geometry in a while. I know you missed me, so I figure if you show me some support, I'll do a little more geometry, a little more often too. I want to talk about interior and exterior angles in polygons and figure out the angle sum. So by the end of the video, we'll get to our goal. You can fast forward, you get to the goal right away, but you're going to miss a lot of information that you need to know. So even though we get to the goal, you still need to know about all the different shapes, about all the different angles, etc. So I have a table here. If you can copy down these columns, all of this is important, not just the goal. You need to know the name of the shape, you need to know the number of sides, the interior angle sum, the measure of each interior angle, each exterior angle, and then the exterior angle sum. So interior angle sum means I add up all the angles inside and I know the sum. Some people say, how could you possibly know the sum before you know each one? Shouldn't you know each one and then the sum? The way I teach it, you need to know the sum first and then each one. Each one is kind of hard. Then you're going to have a whole table full of a bunch of these, not just these two. These two are the ones for my demonstration, but you need all of them. Start with triangle. Put triangle in here. Then quadrilateral. Then, what's the next one? Triangle, quadrilateral, pentagon, then hexagon. You can skip septagon unless you want to do it. Octagon is pretty important. You can skip nonagon unless you want to do it. And polygon is just a general case, meaning you don't know how many sides, so you're going to get a formula. Alright, so I'm going to start with hexagon. This is a hexagon right here. How many sides does it have? 1, 2, 3, 4, 5, 6 sides. And we're assuming that they're all regular shapes. Regular meaning equilateral. All the sides are the same. I might have cheated a little, so it's not exactly the same, but I did use a straight edge and it's pretty close. So we're assuming it's equilateral, assuming it's regular, and it has 6 sides. A polygon, if you don't know what kind of polygon it is, you don't know how many sides, so you say it's an n-gon, it has n sides. N could be 6. If it's a hexagon, it could be 10 or 20, you don't know how many sides. I'm going to develop a formula. Next, I want the interior angle sum, and I learned a trick to find it. I don't know each angle. There's no way I know the measure of this angle A, which happens to be the same as angle B, but I don't know them. But I do know something from a long time ago. I learned that the triangle that has 3 angles, always, and I actually did a video on this based on parallel lines. I used parallel lines to prove it. Triangle has 3 angles that always add up to 180. If you remember that fact, just draw triangles inside your shape. Pick a vertex, angle A. You can pick any vertex you want. I'm going to do A. Connect it to all the other vertices one at a time. Think about what's a vertex. A vertex is a point. So I connect A to B, that's already there. The line segment AB is already there. So then I'm going to draw A to C. You can use a straight edge if you want to be really neat about this. Now I'm going to go A to D. Then I'm going to go A to E. And you can A to F, you should notice, is already there. So I created 1, 2, 3, 4. 1, 2, 3, 4 triangles. The reason I always come out from A is I don't want my triangles crisscrossing in the center. That creates extra angles in the middle that you don't want. I want all these angles here, plus this angle, plus these 2 angles here, plus these angles, plus these angles. And really all that is all 4 triangles added up together. So if you know that a triangle sum, angle sum is 180, and now I have 4 triangles, oh, go get a calculator, do the math. What is this? 720, so my interior angle sum is 720. And how did I get that 720? I multiplied 180 times 4. So I did 180 times the number of triangles. How many triangles were here? 4? But there were 6 sides. There's always, and when you do it for the other shapes, you'll see there's always 2 less triangles than sides. So that's n minus 2. 180 times n minus 2. That's how you get the angle sum. But now, what if I just wanted each angle? Well, if they all add up to 720 and it's equilateral and equiangular, I just do 720 divided by how many vertices there are, how many angles there are. There's 6. So divide by 6. Get your calculator, I'm going to do long division. 7 divided by 6 is 1. Put the 6, subtract, you get 1, bring down the 2, that's a 2, that's 12. 6 into 12 is 2. So I think 2 times 6 is 12, subtract that 0, bring down the 0, there's another 0, there's another 0, 120 each. Angle is 120 degrees. How did I get that? I did 180 times n minus 2 to get the angle sum, and then I just divided by the number of angles or the number of sides. So I divided by n. So that's how you would find it for any, that's how you would find each angle for any shape. Just plug in the number of sides as your n. N equals number of sides. All right, what if I wanted each exterior angle? This is the hard part for a lot of people. An exterior angle is created by extending a base. And any one of these sides could be the base, it doesn't have to be the bottom, but I will start at the bottom. I'm going to take AF, the base. I'm going to put my straight edge flush with AF, kind of trace it, and then extend outside. So what did I do? I created an exterior angle. You notice if you ignore everything else, you see AF and extension. That's a straight line. So this angle and this angle are supplementary. Now you just told me that this angle is 120. So that exterior angle has got to be 180 minus 120. Remember supplementary? So what is that? 60? So the exterior angle is 60 degrees. How did I get that? I did, this is going to look funny, but you know what I did. 180 minus this number, which I got from the previous box. So 180 times n minus 2 over n. That's how I got that. I'm almost there, I'm almost there. Now, this is one exterior angle, but how many exterior angles are there if you extend each base just once? Don't extend it both ways. If I extend AF, I'm only extending to the right. Now I'm going to extend FE, and I'm going to go up like that. Flush, DE. Should I go down? No, I don't want my exterior angles crisscrossing. That adds extra information. So I'm going to extend it up. Let me take CD now, do the same thing. Extend it left. Okay, and CB, I'm going to extend it downward. And I think I'm done, but look carefully. I got 1, 2, 3, 4, 5. Still got to do AB or BA. So I'll extend that one out. How many exterior angles are there? Should be the same amount of interior angles. 6 interior, 6 exterior. I'll highlight them in green. Here's one. We just said that was 60. It's got to be, if that's 120, that's 60. Here's the next one, and it's supplementary with this guy. We said it was 120, so that's got to be 60. This is just happening at every single corner. So this one has to be 60, and this one has to be 60, and this one has to be 60, and this one has to be 60. How many green 60s do you see? Got to be 6. So 60 times 6 is 360 degrees. My exterior angle sum is 360, and it is no coincidence that that is true for every shape. So the interior angle sum is different for every shape, but the exterior sum is always, no matter what the shape is, 360 degrees. And you got that by multiplying this answer by n. So it can be proved algebraically that this thing times n always works out to 360. Not a coincidence. Thanks for watching. See ya.